For this problem, we're going to solve a rational inequality algebraically. We want to solve this inequality, and we're going to write our solution set in interval notation. Just like with polynomial inequalities, the first thing we'd like to do is move everything over to the left-hand side and get the right side equal to 0. This is very important on these rationals, that we don't just subtract into the numerator because we don't have a common denominator. So the first step, I'm just going to write x plus 2 over x minus 3, and just write minus 2. So we know that it's clearly separate from this fraction. Now we do need to get a common denominator before we can subtract these. We think of this as 2 over 1. We need to multiply the top and bottom by x minus 3. So we'll have x plus 2 over x minus 3 minus 2 times x minus 3 over x minus 3, and that's less than 0. Since we have our common denominator, we can combine our numerators. We'll have x plus 2. We're going to do a couple of things here. We're going to distribute our negative and also the 2 at the same time. So we're going to have minus 2x, then negative 2 times negative 3 gives us plus 6 over x minus 3, and that's going to be less than 0. We want to clean this up. X minus 2x gives us a negative x. 2 plus 6 is plus 8. That's divided by x minus 3, and we want that to be less than 0. What we want to do next is determine where this expression on the left-hand side is equal to 0. If we call this expression f of x, we'll see that f of x is equal to 0, where the numerator is equal to 0, and so that's at x equal to 8. We also want to find out where this expression, or f of x on this side, is undefined. So we can say that f of x is undefined. That's going to be where the denominator is equal to 0, and in this case, that's at x equal to 3. We're now going to use a table and the breakpoints that we found to finish solving our inequality. We've got our function f of x is negative x plus 8 divided by x minus 3. We want that to be less than 0. And we're going to use the values x equal to 8 and x equal to 3 to break up the x-axis. We need to write down some intervals. We're going to start at negative infinity, go up to our first breakpoint, which will be 3. We'll go from 3 to the next breakpoint, which is 8. And we'll go from 8 to infinity. Next, we need to pick a number in each of these intervals that we want to test our function at. So in the first interval, negative infinity to 3, we want to pick 0. From 3 to 8, we'll pick 4. And from 8 to infinity, we'll pick 9. Now it's important to know you could pick any value inside each of these intervals, but you want to try to pick something close to the endpoints, something nice to work with. So we used integers, and 0 is a nice number to work with. Next, we want to find the value of f at each of these values that we've chosen. If we plug in 0 into the function, we'll get negative 8/3. If we plug in 4 into the function, we'll get a value of 4. And if we plug 9 into the function, we'll get a value of negative 1/6. So our conclusion is that on this first interval, the function will be negative. On the second interval, the function will be positive. And on the third interval, the function will be negative. We want this function to be negative, and this is a strict inequality, so we're not looking for where it's equal to 0. We want it to be strictly less than 0. So we look at our intervals and see that the function will be negative on the first and third intervals. And so our solution set in interval notation will be negative infinity to 3, use a parenthesis on 3, union 8 to infinity.